factor. Scale factor. And let's say we have, let's say you've got, let's just say you've got a rectangle for right now. And it is a 2 by 4 rectangle, 2 feet by 4 feet. What is the perimeter of this little rectangle? I know that's tough. Perimeter of that is Maddie Roth. Huh?
Well,
Area of that is, Laney Kavarik area is, huh? 8 feet squared, right? This is just 12 feet. What happens when you double it? And that goes to our scale factor. Our scale factor is times 2. So I multiply everything by 2. So instead of, I times 2 everything, this now becomes a 4 by 8 rectangle. The new rectangle, what is its perimeter? Eight plus 8 is 16, plus 4 is 20, is 24. What is its new area? 8 times 4 is 32. So here is what most people get mixed up on. Our scale factor was times 2. What happened to the perimeter? To go from 12 to 24, it was times 2. When you're talking about just length, whatever the scale factor is how much it gets multiplied by. But that's not the case with area. If you look at what happened to the area, it went from 8 to 32. It wasn't just doubled, it was, Jaden? Times 4, quadrupled. Why? Anybody? Because you doubled 2 different dimensions. You doubled it twice, actually. And that is where we come up with, when it comes to area, it is the scale factor squared. My scale factor was 2, I square it, that's how many times bigger the area is. Okay? If by some chance I would have tripled all the dimensions, if I tripled this and made it a 6 by 12 rectangle, I won't draw it to scale, how many times bigger will this rectangle be than the one I started with? My scale factor is times 3. What is times 3 squared? The new one is going to be 9 times bigger. 9 times. It's because I tripled both of them. Which leads us to the last one. When you talk about volume, let's say this, let's make it a 3-dimensional shape. Let's just say it was a 1 thing, so my volume is also going to be 8 feet cubed, right? Because 2 times 4 times 1 is still 8. If I double that, this now becomes 2. My new thing, I doubled every dimension here, my new volume of this one is 8 times 4 times 2, 32 times 2 is 64. What happens to volume? Volume is not scale factor squared, volume is scale factor cubed. Why? Because you doubled 3 different dimensions. You doubled it, you doubled it, you doubled it. And when you double, 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 you take it 8 times bigger. So volume, ladies and gentlemen, is the scale factor cubed. Length doesn't matter because it's just length. Length doesn't matter because you're not multiplying the dimensions together, you add them together. Volume matters because you are multiplying. So with that being said, look at the little sheet that I just gave you. Let's look at a practice problem and see if we can't make heads or tails of this. I don't even know if I can do this. I'm taking a huge risk that I can do this thing, Marco. Look at letter B. Are you with me on your paper there? I'm not saying this is easy. It's a hard concept, but if you think about it, you kind of get it. If you were in the real world, you would get it. If you were an engineer or actually physically doing stuff, you would understand this a little more. An architect builds a 1/50th scale model of a proposed facility building for a client. The volume of the model is what fraction of the volume of the proposed building? So the only thing you need to think about is this. What is that, letter B on your paper? What's the scale factor? What does it say? What is the scale factor? Come on, people. It says there. It's plain in black and white. Brianna the cat. Massey, what is the scale factor? 1/50th, which makes sense, ladies and gentlemen, because if you're building a building, you can't build it one for one because you'd be building the building. So you shrink it down. You know, this doesn't matter, but if it was 100 feet for the building, you'd multiply it by 1/50th, and on the model, it would only be 2 feet. That makes sense because you're shrinking it down. That's not what they ask you here. What do they ask you? The volume of the model. So now all you have to do is think about volume. What do you do to scale factor to get volume, how they compare? Volume is scale factor cubed. So you just take this is your scale factor, that's what it said, you multiply and cube it. Now I know you probably don't necessarily like that, but what is 1/50 times 1/50 times 1/50? Now this is 1/250. And 1/250 times 50 is 1/, gosh, how many zeros is that? 1, 2. Anybody 5 times 25? Is that right? What's that? 125,000. Yeah, because 1, 2, 3 zeros, 5 times 5 times 5. Yeah, I missed this. This is probably 2,500. And guess what my book has for an answer? 1/125,000. Look at you are already smarter than you were 2 days ago. Maddie is celebrating apparently. What about letter C? The large cylinder container has the dimensions 25% greater than the smaller container. The large container will hold what percent more flour than the smaller container? Now here's what you gotta think about it. Let me draw that up for you. Let's just draw this and look at it and see if this doesn't make any heads or tails to you. These were all 4 inches. By the way, you don't have to do any math here, I don't believe. Okay. What is the scale factor? How do I go from 4 to 5? That's kind of the question you have to ask. What would you multiply 4 by to get 5? If you don't know, children, this is why you learned equations. 4 times what number gives you 5? Jaden? Yeah, 1.25. Which is what they said, right? They said it's 25% greater, which means you take 25% of it, add it to it, you get 25% of 4 is 1, you add it to it, you get 5. Now, what are we talking about? We talking about area, volume, or just length for this thing? It says the large container will hold about what percent more than the small container? We're talking about volume, right? When you fill something up, it's volume. So what do you have to do to this? This is your scale factor. Volume is scale factor cubed. And I know you say to me, Mr. Hunt, can we use a calculator? You can. I can. You can't. Just because I don't want to mess around with it. I found if I let you use, so 1.25, this is squared here, do I have to do it out? Times 1.25 about, so here was the question it asked you. Notice it says about, so it's a rounding thing. What percent more will it hold? Huh? Do we agree with Elijah on that? Is 1.95 close to 200%? Sure it is. What does that say? That's 1.95 is what percent? Move the decimal 2 places, it's 195%. Now, unfortunately, Elijah's answer is not right. You wanna know why, Elijah? Huh? Because the question asked you what percent more. This is what percent it is of that. More means how much more would you add to that to get to it. It starts out, you already have 100% there. So how much more would you have to add to it? Another 100%. And that's all semantics. I would give you this just because it's all about the wording that they use. And I'm not gonna do that. Let's just go to letter D. A crate with the given dimensions will hold 24 cubes with 12-inch sides. How many 6-inch cubes will the crate hold? Oh boy. Look at, they give you pictures. This one's actually one that I think you can do. 24 cubes with 12-inch sides. This one I think you'd have to actually sketch out. Let's do this. What are the dimensions of this? 4 feet, 3 feet, 2 feet. 4 feet, 3 feet, 2 feet. Let's get a little crazy here. It says what? This will hold 24 cubes, right? 24 cubes that are, well, it's 1 foot, or you could call it 12 inches on the side. The question asks you how many if they were just 6-inch cubes instead of a foot. Six-inch cubes. What is your scale factor if you go from 6 inches to a foot? 6 inches to 12 inches is what? Huh? Scale factor of times 2. You are talking about surface area or volume in this one? Cubes, when you put cubes in something, it's, so you're going to take that and cube it. What is 2 cubed? So you're going to get 8 times more cubes in there, which is going to give you, you will get 192 cubes in there. Now, could you do this, could you do it out? Absolutely. Okay, this is 4 feet. Well, 4 feet would be how many 6 inches? Each one of these would be 2, right? 6 inches plus 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 6 inches, which is how many 6 inches? 8. 3 would be how many 6 inches? 6 3 feet, cut them each in half, you get 6 of them. And 2 feet would be how many 6 inches? 4. 4 times 6 times 8 is going to give you and hopefully you caught on to some of that. It is not, where does this keep going? Why does it keep looking like that?